Here's the situation in this problem. There are two poles. There's a line hanging between them. And I'm going to say this is on a coordinate plane, and I'm going to call it, they're 8 meters apart, so I'll call this one -4, 0, the point at the bottom of this pole, and the point at the bottom of this pole, 4, 0. That way they're 8 meters apart, just like the question says. And it asks, what is the slope of the tangent line? Oh, I guess I can't draw it like that. What is the slope of the tangent line? What happened? Oh, there it goes. It disappeared. Okay, what is the slope of the tangent line? Trying to find my pencil. What is the slope of the tangent line? I'll say it many, many times. What is the slope of the tangent line where it touches the pole? And then it also asks, what is the angle between that wire and the pole there? So I can imagine here's the x-axis. Here I've got the tangent line makes a triangle between it and the pole, and I've got the angle up there is theta. I've got the angle down here, I don't know what to call it, beta, I'll call it, and this angle is 90 degrees. And I'll call this ABC. This is triangle ABC. So now I've got the situation drawn, and C is at 4, 0. So I can find the slope of this tangent line where it touches the pole if I can take the derivative of that function and then plug in x equals 4, and that will be the slope where it touches the pole. So I am going to, this is 4 something, up here is some y value, but it touches a pole with an x value of 4. So here's the original function, y equals 10 hyperbolic cosine of x over 10 minus 5. And what's the derivative of that? Well, the derivative of hyperbolic cosine is hyperbolic sine of x over 10. The derivative of -5 is 0, so that drops out. And then times the derivative of what's inside, well, the derivative of x over 10 in respect to x is just 1/10. 1/10 times 10 is 1. So that's it, hyperbolic sine of x over 10. And then I can plug in the x value where that pole is, where it touches that line. The x value is 4. So the slope is going to be the hyperbolic sine of 4/10. And at this point, you can get an approximate answer. It's approximately 0.41. But I'm going to use this in my further calculation. So that's the slope. All right, now how am I going to find theta? Well, this is a triangle. The 3 angles together equal 180 degrees. One of the angles is 90 degrees between the pole and the ground. So I know that beta plus alpha equals 90 degrees, or 90 minus that angle beta equals theta. It's what's left over from 90 degrees. How am I going to find that angle beta? Well, one thing I can do is just use trigonometric functions. Beta is equal to the tangent of beta is equal to opposite, that's AC, over adjacent, which is BC. So that also happens to be the slope of this line, of this tangent line, happens to be opposite the rise over run. So this is the rise, how high the pole is. This is the run, how far it is away from this point that I called point B. So I know that the tangent of beta equals the slope at x equals 4, which is the hyperbolic sine of 4/10. Now, I can put in 0.41, but that's only an approximation. I want to go with exact answers. So the tangent of beta is that. The arctangent of both sides, beta, is going to be the arctangent of the hyperbolic sine, hyperbolic sine of 4/10. And theta is just 90 minus beta. So I'll write it over here. It's 90 minus the arctangent of the hyperbolic sine 4/10 or 2/5, whichever one you want. And if I put that into a calculator, it comes out to approximately, I did it on Desmos, you can do it on whatever calculator, 67.669 degrees, 67.67 degrees. 67.67 degrees. So this is B. Part B of the question says, what is the angle up there, theta? And part A, what is the slope? And the slope is about 0.41, or the hyperbolic sine of 4/10.